In this video, we're going to do a bunch of word problems involving inequalities. This is a really important video. I know at this point you might be tired and you may want to skip over this video or give half effort on these word problems, but it's really important to think about algebra from a real world perspective. Because if you aren't a mathematician, all of the math skills you learned are strictly tools that you use to apply to real world problems. And so what word problems do is help you to bridge that gap between the math and the real world. So it's very important. Okay, so first, the distance d that Xena hits a 9-iron is at least 90 yards, but no more than 110 yards. Okay, so the distance that Xena hits a 9-iron, so D is what? At least 90 yards. So greater than or equal to 90. At least, right? But no more than 110 yards. No more than. That's less than or equal to, right? You see how there's an equal to there? No more than. So this is the inequality right here. You could think of this like the solution. We didn't have to set up an equation and solve it. Just based on the given statement, this is the inequality. And you can think about this as an and inequality. So this is a compound inequality, and specifically an and one, a special case of an and one, because you have the situation is 90 is less than or equal to D, and then D is also, right? That's the idea. The distance that Xena hits the 9-iron is greater than or equal to 90, and at the same time, not or, and less than or equal to 110. And you can put this into a 3-part because you have these, the D's are the same here, so you could just bring them together. If these D's weren't the same, then you have to write it as an and statement. Okay, same type of problem. Marilee wants to earn an A in a class and needs an overall average of at least 92. Her test grades are 88, 92, 180. The average of her quizzes is 90 and counts as 1 test grade. The final exam counts as 2.5 test grades. What score on the final exam would result in Marilee's overall average of 92 or greater? All right. So how do we write this average? Let's just write this average first. So the average of all of her scores, so 88 plus 92 plus 100 plus 80. Okay, now then plus 90, and that's just like a test grade. That's her quizzes, which is just 1 test grade. Now the final exam, so we're trying to solve for X. We're saying X is the score on her final exam, right? Now this is 2.5 test grades. Okay, and then the average is 1, 2, 3, 4, 5 plus 2.5, so 7.5. You see, it's like a weighted average. Okay, now what is this equal to, or what's the inequality? We're going to put this as an inequality. This, to get an A in her class, or well, okay, she wants the overall average of 92 or greater. So this needs to be greater than or equal to 92. And so all we want to do now is solve for X, right? And this looks like it's not going to be a 3-part inequality. It's just going to be a normal inequality. The instructions at the head of these problems say to write a 3-part inequality. So I don't know why it says that. But yeah, you can see how you don't worry about the instructions, just go with what the question's asking you. I was thinking maybe if she needs to score between a 90 and 92, that doesn't make sense. So it's just, we're going to say what her test grade needs to be greater than or equal to what? Her final exam grade needs to be greater than or equal to what? So that her final average is a 92 or greater. Okay, so 88. So 450 Okay, yeah, look, this is a linear equation in one variable. Let's multiply by 7.5. So 4. $690. Okay, subtract 450 from both sides. Okay, divide both sides by 2.5. So x needs to be greater than or equal to 96. If she gets a 96 or greater on her final exam, she gets an A in the class, or a 92 average. Rita earned scores of 78, 82, 90, 80, and 75 on her 5-chapter test for a certain class and a grade of 85 on the class project. The overall average for the course is computed as follows. The average of the 5-chapter test makes up 60% of the course grade. The project accounts for 10% of the grade, and the final exam accounts for 30%. What scores can Rita earn on the final exam to earn a B in the course if the cutoff for a B is an overall average score greater than or equal to 80, but less than 90? Assume that 100 is the highest score that can be earned in the final exam, then only whole number scores are given. So I don't know, what do we care about if she happens to get, score in the final exam where her average is greater than 90, then, so to me, we're just going to, let's calculate the score that if she scores at least this on the final exam, she'll have her average will be 80 or higher, but not also less than 90. Okay, so 60% of the grade is on her tests, on her 5-chapter tests. So let's see what percent of 60 that she has, because that's done with. 78 plus 82 plus 90 plus 80 plus 75. Okay, so 81%. She has 81% of that 60. 48.6%. That's the chapter tests. Okay? So, she's trying to get to at least 80, right? She's trying to get at least 80%. All right? Now, she got a 85 on the class project. And that's worth 10%. So that's 8.5%. All right. So is there anything else? No. Okay. So 48.6 plus 8.5, 57.1. And then she has 30% remaining that's remaining credit left in the course. So if you add 57.1 plus 30, if she got 100 on her final exam, then she would have a 97.1% average in the class, because she would get all of that 30% from the final exam. But she needs if she wants to get to 80, so 80 minus 57.1, she needs 22.9%, right? Because plus 22.9% equals 80%. So what is 22.9 divided by 30? %. Okay, so if she scores let's say no, I take that back. Let's say 77%, because I guess if she scored a 76%, she might have like a 79 point something. So let's say 77%. If she scores a 77%, she'll have a 80% average. If she scores higher, well, then great. So 77%, well, let's put it X is her test grade, her final exam grade. This needs to be greater than or equal to 77%. And she'll get a B in the, at least a B in the class. I mean, we can calculate if she wants to get an A. So add 10%. Wait, okay, I messed this up. I'm sorry. So if she got 100% on her final exam, she wouldn't have a 97.1%. She'd have an 87.1%. 57.1 plus 30 is 87.1. So she can't get an A in the class unless there's some form of extra credit on the final. So if she got 100 on her final exam, she'd get all 30% here and have an 87.1% average. A car travels 50 miles per hour and passes a truck traveling 40 miles per hour. How long will it take the car to be more than 16 miles ahead? All right, so we're going to use the distance is equal to rate times time formula. How long would it take the car to be more than 16 miles ahead? So remember, with word problems, you want to try and, you read the word problem, it tells a story. You want to try and rewrite that story with the math formula, okay? So in effect, the car is traveling 10 miles per hour faster than the truck right when it passes it. And it stays that way indefinitely, you can think about it. So the car is traveling in effect at 10 miles per hour, okay? Now we want, let's do this. We want the time. So distance divided by rate is time. So we'll say 16 divided by 10, right? Because time is equal to distance divided by rate. So 16 miles per hour traveling in effect at 10 miles per hour. Well, okay, hold up. I'm not really telling the story here. So how long will it take the distance to be greater than 16 miles? So, all right, RT is the distance. So RT, when is that going to be greater than, more than, right? More than 16. The net speed is 10, right? Okay, you see? So now let's divide both sides by 10. So okay, so 1.6 hours. When the time after the car has passed, when the time is greater than 1.6 hours, the car is 16 miles, more than 16 miles ahead. And 0.6 hours, if you want to put that into like how many minutes, 1 hour and how many minutes, just take 0.6 of 60. A rectangular garden is to be constructed so that the width is 100 feet. What are the possible values for the length of the garden if at most 800 feet of fencing is to be used? So a rectangular garden is constructed so that the width is 100 feet. We'll say this is the width. What are the possible values for the length of the garden if at most 800 feet of fencing is to be used? Okay, so this is the length. So calculating the perimeter, we've got what? 100 plus 100 is 200 plus 2L. That has to be less than or equal to 800. You see? The total perimeter can't be more than 800. It can be equal to 800, but it can't be more. So subtracting 200 from both sides. Okay. L, the length can, at most, the length can be 300 feet. At most. For a certain bowling league, a beginner bowler computes her handicap by taking 90% of the difference between 220 and her average score in league play. Determine the average scores that would produce a handicap of 72 or less. Also assume that a negative handicap is not possible in this league. All right, so the bowler, to compute the handicap, you take the score, or the average scores, you take 220 minus the average score. It's going to be, and the average score is going to be less than 220, right? Because 220 is like the benchmark. Take 90% of that, okay? And this is less than or equal to 72. But you can't have a negative handicap. So let's also solve for x when the handicap, this is the handicap, is greater than or equal to 0. And then we'll get the range of scores. Okay, so let's solve this on the left here. So distributing that 0.9, 198 minus okay, so 72 minus 198 minus 126. So now divide both sides by negative 0.9. Okay, now flip the inequality, right? We just divided by a negative number on both sides. So 140. Okay, and now here, to make this greater than or equal to 0, let's just solve this because it's a little confusing. I'm tempted to just set 220 minus x greater than or equal to 0, but with the inequality, it's a little different. So 198 minus so 0.9x is less than or equal to 198, right? And then okay, and this makes sense because if you bowl a 220, your average score, then your handicap is 0. You have no handicap, right? The worse your average score is, the larger your handicap. So if your average score, let's write this here. This is it's asking us the average scores. There's the average scores. Less than or equal to 220, greater than or equal to 140. All scores that are between 140 and 220 inclusive, then that results in handicaps of 72 or less. Donovan has offers for 2 sales jobs. Job A pays a base salary of $25,000 plus a 10% commission on sales. Job B pays a base salary of $30,000 plus 8% commission on sales. A, how much would Donovan have to sell for the salary from job A to exceed the salary from job B? Okay, so that's going to be X, that selling the sales in job A. Well, okay, let's try and write this out here. So job A, we've got 25,000 plus 10% X. And we're just going to say X because X is the amount he sells. So like, in other words, I was tempted to put XA and XB, but he's just trying to find out, okay, how much, like he knows how hard it is to sell. He's saying, okay, how much do I need to sell just in general? Because selling is the same difficulty at both jobs. How much do I need to sell at job A, right? Because job A pays a base salary of less, but the commission is more. What is the minimum amount I need to sell so that my salary in job A would exceed that of job B? If it's not too much, well, then I'm going to take job A, right? If I know I can sell that much, no problem, then I'll take job A. So this needs to exceed, it says, greater than, right? Not greater than or equal to. It needs to be greater than, not greater than or equal to, because if it's equal to, then just take job B, right? Okay, so is greater than 30,000 plus 0.08x. Let's just solve this inequality. Let's subtract 0.08 from both sides. Okay, let's subtract 25,000 from both sides. So we get that X needs to be greater than $250,000. Okay, he needs to sell at least $250,000 of merchandise, not at least, greater than, for the salary of job A to exceed that from job B. All right. If Donovan routinely sells more than $500,000 in merchandise, which job will result in a higher salary? Well, job A, right? Because that's greater than that those sales are greater than $250,000. We just solved for that. Any sales number greater than $250,000, then the commission from job A is more. Okay, for these last set of problems, we're going to have absolute value inequalities. We want to write the inequality first and then solve it, just like we did with the previous problems. So the variation between the measured value V and 16 ounces is less than 0.01 ounces. Okay, so the measured value V and 16 ounces, right? The absolute value of this, it doesn't matter if it's above or below. It's like an error. We want the error, well, not equal to, we want the error to be less than 0.01 ounces. Okay, now we have an absolute value inequality. Let's just solve it. We use, this is our rules here. So if the absolute value of some expression is less than, that's what we have, a real number, then you solve this. Okay, so V minus 16 is less than 0.01. We solve this compound inequality here. All right, let's add 16 to all sides. Okay. And this would be 16.01, and that's ounces. The value of X differs from 4 by more than 1 unit. The value of X differs from 4, okay, in either direction by more than 1 unit. For what values of X is the difference between X and 4? Right? So like, think about how that statement sounds. It's suggesting that it's just like, it doesn't matter which direction. So you put an absolute value. That difference is greater than 1. Okay, so let's solve this inequality. We've got this here, so it's an or statement. U is less than minus K, or U is greater than K. U, this is our U, is less than minus K, or U is greater than K. So how do we do this? We worked a whole video on absolute value inequalities. So add 4 to both sides, and then add 4 to both sides here. Okay, so now we just need to just interpret what this is. X is less than 3 or X is greater than 5. Okay, so X is less than 3, so put like an open circle here, everything in that direction, or X is greater than 5. That's the solution set. You plug in any number that's less than 3 or greater than 5, and it solves this inequality. A refrigerator manufacturer recommends that the temperature T inside a refrigerator be 36.5 degrees Fahrenheit. If the thermostat has a margin of error of no more than 1.5 degrees Fahrenheit, so part A, write an absolute value inequality that represents an interval in which to estimate T. Okay, so we want to estimate T based on the thermostat reading. Okay, so I'm not sure what, I guess it's supposed to be 36.5 degrees Fahrenheit. So we're saying that the actual temperature, the difference between the actual temperature and 36.5 degrees, no more than, so that it's less than or equal to 1.5. I don't like how this problem is stated. The refrigerator manufacturer recommends that the temperature inside a refrigerator be 36.5 degrees. So I guess you set it to that. You set to 36.5 degrees, but the thermostat has a margin of error of no more than 1.5 degrees. So the actual temperature in the refrigerator is going to be what? Like what's a range for what the actual temperature will be? I guess that makes sense. Okay, so we need to solve this inequality here. So we've got a less than. So we're going to do this compound and inequality. So we've got T minus 36.5 is less than, okay, and then, okay, now let's add 36.5 to all sides. Okay, so we've got what? 35 is less than T. Oh, wait, no, this is less than or equal to. Less than or equal to T is less than or equal to 38. Okay, so there we go, and that's degrees Fahrenheit. And then part B, solve, well, okay, we solved the inequality. Yeah, we just did that. Okay, so interpret the answer. That just means that if you have it set to 36.5 degrees, then the actual temperature is going to be somewhere in this range, between 35 and 38 inclusive, based on the margin of error of the thermostat. All right, last problem. The results of a political poll indicate that the leading candidate will receive 51% of the votes with a margin of error of no more than 3%. Let X represent the true percentage of votes received by this candidate. So X is the true percentage of votes received by the candidate. Write an absolute value inequality that represents an interval in which to estimate X. All right, so the actual percentage received minus 51, right? The difference between that percentage and 51, just the absolute value, no more than. So this will be less than or equal to 3. Okay, so we'll use property 1 here. X minus 51 less than or equal to 3. All right, now let's add 51 to all sides. So we've got 48. Okay, so this is the percent, right? The candidate is expected to receive between 48% and 54% of the vote inclusive.